Hi, everyone. Welcome to lesson 1.9, where we're going to review applications of linear systems. So we can apply algebraic substitution and elimination to solve real-world situations that are modeled by linear systems. So when we solve real-world problems, it's important to have a strategy for success. So here are a couple of steps that I suggest when you're faced with an application problem. So of course, number one, we need to understand the problem. Sometimes it helps to rewrite or write out the problem in your own words. And before you even decide to add any variables. The next thing that's important is to have let statements. So once you understand the problem, it's time to choose variables and write down what they represent. Number three, formulate a strategy. Since we are dealing with linear systems here, we're probably going to be using substitution or elimination as our strategy for solving the problem. We will not take a look at graphing to solve word problems. Then we're going to we'll solve the system. And at the very end, you want to go back and check your solutions and see if they make sense in the context of the original problem. All right, so let's take a look. In example one, we have a drama class. They earn $1,040 from a production, a total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents the situation. What is the price of each type of ticket? So over on the right, kind of went through some of the strategy with you. So for number one, we want to understand the problem. Here's how I would rewrite it. So I know the total number of adult tickets and student tickets sold and the relationship between the price of an adult ticket and the price of a student ticket. And I need to write a system of equations that represents the situation and find the price of each type of ticket. So I start to break the question down a little bit. I know I have 64 tickets, adult tickets, but I don't know the price of the adult tickets. And then I also know how many student tickets were sold, but I don't know the price of the student ticket. And in total, I do know how much money was made for this production, which is $1,040. There's one other piece of information. I do know the relationship in price between the adult ticket and the student ticket. The adult ticket is twice as much as the student ticket. All right, so now I feel like I have a good understanding of my problem. Let's write down the let statements. Step two, since I'm looking for the price of each of the separate tickets, I'm going to say let X represent the adult ticket and Y represent the student ticket. And from here, we're going to come up with our system of equations. So I'm going to move over a little bit here so I have some space to write. So again, we can replace some of the words and verbiage with variables now because we have our let statements. So if I have 64 adult tickets, I would have to multiply that by the price of adult tickets. Then I would add 132 student tickets times the price of the student ticket. And in total, that brought in the revenue, which was $1,040. So here I have one equation. But we need another one because we're building a system. Well, it did say that an adult ticket is twice as much as a student ticket. So that can be written as X equals 2 times Y, twice as much. And this gives me a second equation. Now here, it looks like I can just use substitution. So that is going to be my strategy. And 64 will plug in 2Y here, plus 132 times Y is equal to 1,040. I'm going to go ahead and keep simplifying. I will have 128. Obviously, I do these calculations with a calculator. 132y is equal to 1,040. Adding the two terms of y, I will get 260y is equal to 1,040. I divide through by 260 and I get y is equal to 4. So now that I have y, I want to sub it back into one of the equations at the top to find my x value. So I'm going to sub this into, the simplest one looks like 2, so I'm going to sub it into equation 2. And x is going to be equal to 2 times 4. So x is 8. All right, now let's look back at the context, right? So x and y, x is the price of an adult ticket and y is the price of a student ticket. So as it turns out, it looks like the adult tickets are $8 and the student tickets are 4. So we want to make a closing statement that does seem to make sense with the context of the problem. So we usually write closing statement as therefore the price of an adult ticket is $8 and the price of a student ticket is $4. All right. So let's take a look at a second example. In this situation, we're dealing with a math test. So a math test is worth a total of 100 points. It has 38 problems in total, and each problem is worth either 5 points or 2 points. How many problems of each point value are on the test? So, understanding the problem, we have a math test, we have a total of 100 points and a total of 38 problems. We have only two types of problems. One type is worth 5 points and the other type is worth 2 points. So since I want to find how many problems of each point value are on the test, that's where my let statements come in. So let's let x represent the number, I'm just going to use short form here, of, let's see, 5-point problems. Let's do the 5-point problems. So then we'll let y represent the number of 2-point problems. So we're going to build our system of equations based on the total number of points that there are for this test, but also based on how many problems there are on the test. So let's start. We know that there are 38 problems on the test. So if we have a total number of 5-point problems and we add that to the total number of 2-point problems, that will give me 38 total problems on the test. But if I want to know how much things are worth, we know it's a total of 100 points. The 5-point problems, we would have to multiply by x. And the 2-point problems, we would multiply by y. And that would give me a total of 100 points. All right, so I have equation 1 and I have equation 2. And it seems to me that I might want to use substitution, but I will have to do some manipulation first. So I'm going to go ahead and take 1 over here, and I'm going to solve it for x. So x equals 38 minus y. So I've isolated for x. Now I'm going to sub that into 2. So I'm going to sub 1 into 2. So 5 times 38 minus y plus 2y equals 100. There's my substitution. I have 190 minus 5. That's distributing the 5 into the brackets. Minus 5y plus 2y equals 100. I'm going to move my 190 over to the other side. It's going to become negative, and I'm going to collect my y terms on the left. So I will end up with negative 3y and negative 90 on the right side, because 100 minus 190. Let's go ahead and divide through by negative 3, and my y will be 30. Good. Now that we have y, we're going to sub it into, let's say 1 to solve. So x equals 38 minus 30. So x is equal to 8. So what does this mean? It looks like from these solutions that I have 8 5-point problems and I have 30 2-point problems. And that seems to make sense relative to what our situation is. We make a statement. All right, at the end, therefore, there are 8 5-point problems and 30 2-point problems on the test. Great. We have a couple more to look at. So let's take a look at example 3. A business has 2 locations, and the 2 locations, they buy 7 large delivery vans and 5 small delivery vans. We have 2 locations. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. And location B receives 2 large vans and three small vans for a total of $160,000. So what is the cost of each type of van? So what I'm looking at here as far as understanding the problem is I have to break this down into, there are 2 types of vans and there are 2 locations. So I'm thinking, how am I going to create the system of equations based on those 2 categories? So since we want to find the cost of each type of van, let's write our let statement. Let X represent the cost of, let's say, the large van. So we'll let Y represent the cost of a small van. So let's break this down into the 2 locations, and each of the location will end up giving me a linear equation to deal with. So if I take a look at location A, location A has 5 large vans and 2 small vans for a total cost of $235,000. So location A has 5 large vans plus 2 small vans, and they total $235,000. So now let's consider location B. Location B, they have 2 large vans and they have 3 small vans. and that totals $160,000. All right, so it seems here that my strategy to deal with this is probably going to be elimination, except recall that in elimination, we need to have the same coefficient either on the x terms or the y terms. So let's go ahead and change. What I'm going to do is I'm going to take this equation 1, and I'm going to multiply that by 2, and I'm going to take equation 2, and I'm going to multiply that by 5. And what that is going to do is it's going to create the same coefficient for the x term. So let's do that. So for location A, I will have 10x plus 4y equals 470,000. And then for the other equation, I'll have 10x, 3y times 5 plus 15. Y is going to be 800,000. So now I have coefficients of 10 and 10. And if I subtract using elimination, the x's will cancel. And I'll have 4 minus 15, so that's going to give me negative 11y. And 470,000 minus 800,000 is going to be negative 330,000. If I divide through by negative 11, I will get a y value of 30,000. I'll go back and substitute this y value into equation 1 or 2, and I think I'll just do 7 to 1. So 5x plus 2 times 30,000 is equal to 235,000. 5x, 2 times 30,000 is going to give me 60,000 equals 235,000. I'll go ahead and subtract that 60,000. I will have 5x is equal to 175,000. And finally divide through by 5, and x will be 35,000. So there we go. So let's recall what x and y are. X was representing the cost of a large van, and y was representing the cost of the small van. So x as $35,000, y as $30,000 seems to make sense. All right, so therefore, the cost of a large van is $35,000, and the cost of a small van is $30,000. All right, so here we go. This is our last example. So you pay $21 for 4 gallons of gas and 3 quarts of oil at a gas station. Your friend pays $24.50 for 2 gallons of gas at the same gas station and 5 quarts of the same oil. So determine the cost of 1 gallon of gas and 1 quart of oil. So seems to be pretty straightforward. Our two situations and our system is going to be built on the fact that we have two people buying two separate things. So we'll talk about what you buy and we'll talk about what your friend buys as far as understanding the problem. So we need to find the cost of 1 gallon of gas and 1 quart of oil. So let's put in our let statements. So let X represent, let's let X be the gallons of gas. Let X represent the cost of 1 gallon of gas. And we're going to let Y represent the cost of 1 quart of oil. Good. Now let's talk about you and let's talk about your friend. So for you, you bought 4 gallons of gas. We don't know how much the gas costs per gallon. And then you bought 3 quarts of oil, but we don't know how much the quart cost. But in total, you spent $21. Now for your friend purchased 2 gallons of gas, but got 5 quarts of oil, and your friend paid $24.50. So we determined equation 1 and equation 2. Also looks like somewhat of a setup for elimination, but I don't have the same coefficients. So what I'm going to do is I'm going to take equation 2 and I'm going to multiply it by 2. So that's going to give me 4x plus 10y is equal to $49. I'm going to bring equation down underneath. 4x plus 3y equals 21, because I like to have things lined up for elimination. And we can see that now the coefficients on the x term match, so we can subtract and eliminate the x's. So we'll cross those off, and then 10y minus 3y is going to give me 7y. And 49 minus 21 is going to give me 28. And if I divide through by 7, I'll have y is equal to 3. I'm going to go back and substitute that into, I guess, 2. We can do that. Sub into 2. And I'll have 2x plus 5 times 3 is equal to 2450. 2x plus 15 is equal to 2450. 2x is equal to, subtracting 2450, subtract 15 is going to give me 950. And then dividing through by 2 on each side will give me x equals 475. So let's go back and take a look. The context of the problem. X is the price for a gallon of gas, which here is $4.75. And then the quart of oil is $3. So let's go ahead and make that final statement. Therefore, a gallon of gas costs $4.75, and a quart of oil costs $3. All right, good job. We're done with this lesson and we'll be moving on to Unit 2 soon. All right, see you later.